This is CPM Precalculus Chapter 2, number 112. Let f of x equal to the square root of x squared plus 5. Okay. Part A. Graph the function for 1 is less than or equal to 6. 1 is less than or equal to x is less than or equal to 6. So we want to graph it between 1 and 2, 3, 4, 5, 6. Okay, so we only want to graph it between here and here and ignore the rest. So let's go ahead and bring out our calculators. Graph the square root of x squared plus 5. And that's going to look sort of like a parabola, but less round here. As we can see, we have the square root. Okay, so this we know we can go ahead and if we do second and go to trace here, above says calculate, we can get the value at 1 and 6. So let's use this calculator and say at x equals to 1, what is y? So at x equals to 1, y is 2.449. It says right here. So I know at x equals to 1, y is around right here, 2.449, right? And at x is equal to 6, what is it equal? What is y equal? So I'm going to do second again, trace, calculate, and I'm going to do value again. So at x is equal to 6, it asks me, I'm going to write 6 in there, press enter, and then it shows me that at x is 6 here, y is 6.403. So I can go at 6 here as my x value, 6. My y value goes up to 1, 2, 3, 4, 5, 6.4. So it's all the way up here, right? And I'm just going to connect these, see how it just connects. And the graph looks something like this. It's not exactly a line. It's curved, but it's pretty linear, right? It doesn't look too curved. All right, so there's my region. Get rid of the calculator. All right, so we graphed it for 1 is less than or equal to x is less than or equal to 6. Okay, so we're not graphing to the left of 1 or to the right of 6. We're just on the domain from x is 1 through x is 6. All right, and remember these are closed circles because it's or equal. So part B says to find the upper and lower approximations for the area by using 5 right endpoint and 5 left endpoint rectangles. So we know we can quickly go from left endpoint, right, to right endpoint, or the other way, but we can go quickly from one to the other by just looking at the indices, right? We have some, I don't know, we'll say something here where we're starting with, I don't know, n is equal to, let's not use n, let's just say k is equal to 1 to some, I don't know, some value b. So we can go from left endpoint to right, remember, just by adding 1. So if we say k is equal to 1 plus 1 is 2, and it stops at b plus 1 of our same expression, and that's how we go from left to right. Okay, so knowing this, I'm going to put it in a little cloud, right, because we're just showing here, we're just adding 1, right, that plus 1 to go from left to right, we're adding 1. Let's go ahead and just find the left endpoint representation. Okay, the left endpoint rectangles. All right, so using left endpoint rectangles, I know the area, right, between my function and it's called f of x. So I'm going to say between f and the region 1 to 6, 1 is less than or equal to x is less than or equal to 6 is approximately, and here's where I'm going to go ahead and write that equation, right? But first of all, this problem doesn't ask me all of the small parts, it's just asking me the big part. So what do I need to do? I need to find the base or the width, right? The width of every rectangle is just, I know, b minus a over n. And I'm going from 1 to 6, and 1 is my a, 6 is my b, so it's 6 minus 1 over n. I'm using 5, right? I'm using 5 of these rectangles, so it's over 5. 6 minus 1 is 5 over 5, that's equal to 1. So I know the width of each rectangle is 1, right? So I can even draw these on here. It's gonna, basically the bases are 1, 2, 3, 4, 5. Like these are my regions from 1 to 2. And I'm going to start using, remember, left endpoint. So let me go ahead and draw this in, right? At 2, I go up here. So these are my rectangles. Left endpoint rectangles. Right? These are my 5 rectangles. And I want to go ahead and find the coordinates of every point here, right? That's touching the curve. And what is my curve again? My curve is right here, f of x. I'm going to write that down. F of x is equal to the square root of x squared plus 5, right? So the first point here is x is 2, right? I mean x is 1, excuse me. X is 1, the y value. So I'm going to write 1 comma, the y value is 1 squared plus 5 square root. So the square root of 1 squared plus 5, right? That's this point. This point right here, I'm going to write it up here. It's going to be the x value is 2, and the y value, again, I'm going to plug 2 into the x here, so it's going to be square root of 2 squared plus 5. This point right here, I'm going to go ahead and move this up just so I have room to write all of these. The x value here is 3. The y value, again, I'm going to plug into the formula, so it's square root of 3 squared plus 5. This point here is 4, comma, right? The x value is 4. I'm going to move it up here just so you can see it better. Comma square root of, now it's 4 squared plus 5. And this point here is 5, right? The x value here is 5, comma 5 squared plus 5, right? And so we can see that the area then, the base, remember, is the same as the width. So I could say is equal to the base of every rectangle. And that's equal to 1, right? So the base is 1 times the height. So the height of my first rectangle is just 1 squared plus 5 and the square root of that. So times square root of 1 squared plus 5 plus the base of the next one is 1 again. They're all 1. The height is square root of 2 squared plus 5 plus, again, the next rectangle. So we did these. So this one right here, the base is 1 again. And the height is putting the 3 into the function, so we get square root of 3 squared plus 5. Square root of 3 squared plus 5. Again, the next rectangle right here, and we get the base is 1 times the height is 4, the square root of 4 squared plus 5. And finally, we have the base of 1, and we have 5 squared plus 5, right? Whoa, excuse me. 5 squared plus 5. So let's go ahead and find the representation in sigma notation, right? So what do you see here? Given left endpoint rectangles, we see the 1 is the same, but since we're multiplying by 1 every time, that does not change the value. So we can go ahead, we can erase that 1, and it doesn't change anything, right? 1 times anything stays the same. So let's erase it, right? Let's not even worry about the 1. And what we see then is everything's constant except for this number, right, being squared. And that number is going, we're going to add 1 every time, right, to get to the next one. Plus 1, plus 1. So that number there is the linear series in our series. So we know that this is equal to the sum and let's say, I don't know, k is 1. This is the first term, second term, third, fourth, fifth. So we know we're going from 1 to 5. And it's the square root of something squared. I'm going to write that in red, that something, right? That something squared, because that something is changing. That's our linear series plus 5. So let's go ahead and find out what that linear series is. So our linear series is in the form of y is equal to mx plus b, but we know it's in the form of m is 1, right? We're adding 1 each time, so it's 1, and our variable we're using is k plus b. So we know at k is equal to 1, the first term, our output is going to be 1, right? So at k is 1, then we have k is 1, we have y is equal to 1 as well. So let's go ahead and solve this equation. Let's rewrite this. So we have 1 times k, so k is 1, so let's write 1 times 1, plus b is equal to 1. So 1 times 1 is 1, plus b is equal to 1. Subtract 1 from both sides, we get b is equal to 0. So that gives us y is equal to 1k plus b. Okay? And that means we just need to put into our series here just, oops, not b, plus 0, because we found b is 0. So that's the same thing as just 1k or k. Again, we don't, just like we erased the 1's times here, we don't need to write that here either. So we can just write k, right? So it's just k squared here. And in fact, you might have seen that, right? You might have seen that right away. K is 1 to 5. You're just going from 1, 2, 3, 4, 5. So it's just k. And you might not have had to do all this. But anyway, we see that this, again, is the left endpoint. So go ahead and find the right endpoint then. It's just going to be the area, the same thing, right? And it's going to be approximately. Now we're going to start at k plus 1. So that's 1 plus 1 is 2. And we're ending at this stopping index plus 1 is 6. And we have the same thing here as our expression. Okay? So let's go ahead and plug these into our calculator to find the sums. Right? Because we have a program that will do it all for us. So let's go ahead and run the program, sum plus. So our left endpoint, we're going to start here. So this equation, we're starting at 1, we're stopping at 5, and our argument, our expression is the square root of, and instead of k, remember I'm using x squared, x squared plus 5. Okay, so I get my left endpoint rectangles gives me 19.25, right? Let's make this approximately 19.25 units squared. Okay, and then let's also go ahead and run the program again. And now we're going to start 2 to find our right endpoint. 2 to 6. We have the same expression, the square root of x squared plus 5. And we get, that's approximately 23.20 units squared. Okay? So let's put away our calculator, and let's make sure we're answering the question. Find the upper and lower approximations of the area using 5 right endpoint and 5 left endpoint. Okay, so that's what we did. Which one is our upper and which one's our lower estimate? So 19.25 units squared. This one is going to be, well, which one's bigger? So the one that's bigger is our upper estimate, right? And the one that's smaller here is our lower estimate. Okay, so we know the actual area is in between both of these, right? We can find the average of these is going to give us a closer approximation. But we see here that right endpoint rectangles gives us 23.20 units squared as our upper estimate. That's the estimate. And for our left endpoint rectangles up here, that's going to give us 19.25 units squared, our lower estimate. Alright, so that ends for us CPM Precalculus Chapter 2, number 112.